For those interested in delaminated cementum, we did a brief study kind of looking at this and seeing really what this cementum actually looked like. So if you look at this case that Pushpak sent me, we're going to be looking at this material here, which we are defining as delaminated cementum. And when I got it from Pushpak, these were this was the material found in the biopsy bottle. So because it was in pieces, I decided to look at it three different ways, both with H&E standard histological processing, and then looking at it under the scanning electron microscope. And a couple pieces we looked at actually under the transmission electron microscope, just to see what we could see and if we could gain any clarity about what this material really is like in vivo. So when you look at a piece that's stained normally with H&E, the pieces are basically decalcified and then dehydrated and then mounted in paraffin and then stained. So when you look at this and then those slides are scanned in, you get a sense that maybe there's something here that is bacterial in origin, but when you look at the actual interior part of the cementum, it doesn't really look like that altered in anatomy or morphology. It looks like pretty much normal cementum. And when you look carefully at higher mag, you can say, well, okay, maybe there's something going on here that looks like a bacterial colonization, and you would expect in a periodontal pocket like that the surface, certainly on the ligament side, would be infected with bacteria. But then when you actually stain it with a different stain that highlights stain specifically for bacteria, which is the Brown and Bren stain, here you get a different appreciation of what's really going on in this cementum, because the bacteria are not only on the edge, on the surface of it, they are completely throughout the cementum. So it isn't just a surface contamination with bacteria. Here's another Brown and Bren stain at a little higher magnification, and you get a sense that there's quite a bit of bacterial contamination here. Now we also took this and we stained it with GMS stain, which stains specifically for fungi. It replaces the carbohydrate in the cell wall of the fungi with the silver, and it stains black. So here the GMS stain would indicate that there's significant fungal impregnation of the cementum, and not just on the surface, but all throughout the cementum. So it actually looks on these slides as though the fungal contamination is even more than the bacterial contamination. So these are all fungi using the GMS stain. So then we took some of these pieces and we looked at it under the scanning electron microscope. Now with the scanning electron microscope, the material again is, and then it's dehydrated, and then it's sputter coated with gold to be able to image it under the SEM. And when you look at this, you see a lot of fibrous connective tissue on the surface of the cementum. But if you look really carefully, almost everywhere, you have this fibrous connective tissue, which you would expect. But you also see on the surface a lot of both fungal and bacterial organisms. This has a fungal and bacterial signature to it that is actually quite extensive. So you see some classic cocci and rod-shaped bacteria and fungal morphotypes as well. This is kind of a standard fungi kind of appearance. So this is a combined biofilm without question that contains many, many different kinds of bacteria and fungi. And no matter where you look on this, if you look carefully, you can see these morphotypes pretty much everywhere. Kind of a standard fungal morphotype is this type of morphology. And again, these are fungi in this kind of collection of bacterial biofilm. Now, when we look at the TEM, this is done a little bit differently. The specimen is embedded in plastic, and then the plastic is put on a microtome, and these slices, the epoxy is sliced very, very thin. These are 70 nanometers thick, and then these slices are picked up in a loop and placed on a grid. That's what the grid looks like. And there's the loop with the specimens picked up on it. And then it's laid down on top of this grid. And then it's placed into the TEM. And this is what it looks like. There's the section. And when you look at higher mag, now you get a little bit different appreciation of what this biofilm actually looks like. And here again, you can see this fungal morphotype well within the body of the cementum, not just on the surface. And these are what these biofilms look like. They're obviously many, many different morphotypes here, and it looks very similar to an endodontic biofilm. And I think it's pretty clear here. You have both gram-positive and gram-negative organisms here. These ones with the thicker cell wall are clearly gram-positive organisms. And then you have some fungi here as well. Some really weird-looking organisms. They look kind of nasty. But they're busy working on this cementum. And there's a typical fungi. You can tell by the very thick cell wall of the fungi. Here you can see some budding going on. And again, this is deep into the cementum. This isn't anywhere near the edge of the cementum. So this material is within the body of the cementum. Again, within the body of the cementum of a fungal morphotype. So it might be worthwhile to consider how these got there and whether the delamination is related to this kind of bacterial and fungal impregnation as the cementum is formed over its lifetime. Here you can see a standard biofilm look. This is the collagen of the cementum. So it's a pretty dense biofilm. So going back to the H&E, I think you get a sense that maybe it's not perfectly normal cementum, and you'd expect some bacterial contamination along the outside edge, but we're finding it actually within the body of the cementum. So I thought people might be interested in kind of looking at what we found by looking at this sample.